Well, welcome back. We are going to be working on Unit 3, Lesson 9, Mixed Problem Solving, page 109. So go ahead in your black notebook, write Unit 3, Lesson 9, Mixed Problem Solving, page 109. All right, least common multiples. Let's just take a look at this page. Actually, I'm going to go to the next page here. And it goes on to say the denominators of several pairs of fractions are shown below. 4, 8, 4, 3, 4, 6, 5, 10, and so on. And then it goes, list each pair of denominators beside the case that best describes it. And we're just going to do this together. So number one, case um, A. It says list each pair of denominators beside the case that best describes it. Think about the strategy you would use to find a common denominator for the pair. So one, case A. One denominator is a factor of the other. So 4 goes into 4, and 4 also goes into 8. So 4 and 8 would be 1. 5 and 10, because 5 goes into 5, but 5 also goes into 10, and 10 also goes into 10. 6 and 12 would be another pair. 6 goes into 12, and 12 goes into 12, and 6 goes into 6. And then it goes on for case B. The denominators have no common factors. So 4, 3, the only factor that they have in common really is other than 1. I'm sorry, other than 1, 5 and 7, and 6 and 7. So copy that down for case B. And then case C says the denominators have a common factor that is not one of the numbers and is not 1. So um, 4 and 6, 2 goes into 4, 2 is a factor of 4, and 2 is a factor of 6. 8 and 12, um, 2 is a factor of 8, 2 is a factor of 12, 4 is a factor of 8, 4 is a factor of 12. And then the last one, 6 and 8. 2 is a factor of 6, and 2 is a factor of 8. Then it goes on down below in problem number 2. Go ahead and copy this down, by the way, sorry. The least common multiple of two numbers is the least number that is a multiple of both numbers, and then it wants you to find the LCM of each pair. So there's your definition. We'll copy it in a little bit here. Um, let's look at this first set here. 2A, 2B, 2C, and 2D. 4 and 6, if you were to find the LCM of 4 and 6, it would be 12. 4 goes into 12 3 times, 6 goes into 12 2 times, and it's the least common multiple. Letter B, 4 and 10 would be 20. 4 goes into 25 times, 10 goes into 20 2 times. Letter C, 6 and 8 would be 24. 6 times 4 is 24. 8 times 3 is 24. And the last one is letter D, 6 to 9, 18. 6 goes into 18 3 times. 9 goes into 18 twice. Just some other examples there, but we're going to move on. Definition, copy in your black notebook, least common multiple, LCM, the least number that is a multiple of two or more numbers, and then copy this example. 36 is the least common multiple of 9 and 12. In other words, that's the smallest number that 9 will go into evenly and that 12 will go into evenly. Copy that definition down. All right, if you would turn to page 110, I'd like to look at problem number 6. It says write an equation and use it to solve the problem. Let's just go ahead and isolate number 6 here on page 110. All right, so here's our problem. I'll just move things around here. I'm going to lock it in place so it doesn't move on me. All right, so it wants me to write an equation. Here's the problem. In a frog hopping contest, the frog that hops the farthest in 2 hops wins. On the second hop, your frog hops 3/8 a yard. He hopped a total of 15 over 16 yards. How long or how long was his first hop? So that's where we have to write the equation. We know it to be n plus 3/8 equal 15 over 16. N plus 3/8 equals 15 over 16. And then we'd have to solve it for n. A number plus 3/8 equals 15 over 16. Now, opposite of addition would be subtraction. So if you took 15 over 16 and subtract 3/8 from it, we could figure out what n would have to equal. So but basically you're isolating n by itself. So I'm subtracting that out. And now n equals. All right, common denominator, 16 and 8. Hopefully you recognize that 8 goes into 16. So there's your common denominator. Eight times 2, 3 times 2 is 6. 15 minus 6 is 9 over 16. So n would have to equal 9/16. So for your final answer, you would have 9/16 yards. And that would be what n equals. And that's the first hop, right? Let's take a look at, let's jump down to number 8. Let me move this out of the way. Let me isolate number 8 and take a look at it. All right, Diana and James are painting a room together. Diana paints 1/3 of the room and James paints 1/4 of the room. How much of the room have they painted? So again, you want to write an equation. We're trying to figure out how much total. So we could set the equation up as 1/3 plus 1/4 equals our variable n. There's your equation. How do we solve this? 1/3 plus 1/4. Common denominator, look at the 4, look at the 3, 4 and 3, hopefully you recognize 12, 4 times 3, what you do to your denominator, do to your numerator, 3 times 4, 4 times 1, and then you add 4 plus 3 equals 7 over 12, so your answer would be 7/12. N equals 7/12 of the room. Let's take a look at page 111. A couple problems here. Why don't we start with number 13? On page 111, number 13. Let me just isolate it and solve it. All right, there it is. 2/3 plus 1 2/9. Again, I would set it up 2/3 plus 1 2/9. Looking at the common denominator of 9. Why 9? Because 3 goes into 9 and 9 goes into 9. So this still becomes 2/9. And this is 3 times 3. What I do to my denominator, I do to my numerator. And you end up with 6. 6 plus 2 is 8. 8/9. Don't forget about your whole number. Final answer, 1 8/9. Let's take a look at number 19. In 19, you have an addition problem with decimals. And again, it's important that you line them up. 2.15, 5.2. Now remember, just because there's not a 0, there's one there. Now, I know that 5 plus 2 is 7, so my answer better be close to 7. Bring your decimal down, 5, 3, and 7. 7.35. 7 and 35 hundredths. And let's take a look at one last problem here, number 25. All right, black notebook, 25, 3 and 3/10 minus 2 and 5/8. Now, if you look at the 10 and you look at the 8 and you say, well, 80, because 10 times 8 is 80, and you could use that as a common denominator, but is there a smaller number that 10 will go into and that 8 will go into? Hopefully you recognize it to be 40. So set it up 3 and 3/10 minus 2 and 5/8. Common denominator, 4. Let's just get rid of that. Sorry, that's supposed to be a 40. And 40. All right, so now 8 times 5, so 5 times 5 is 25. 10 times 4, so 3 times 4 is 12. And now we have a problem. We cannot subtract 25 from 12, so we have to borrow. Borrow from the 3, making it 2, but this is where it gets tricky. Pay close attention. What we are borrowing is 40 over 40. Why? Because that's one whole. Our denominator is 40. 40 plus 12, we're now up to 52 over 40 minus 25 over 40. So off to the side, what is 52 minus 25? I have to borrow, make it out of 4, make that a 12. 12 minus 5 is 7. 27 over 40. Don't forget about 2 minus 2, which is 0, so your final answer is 27 over 40. All right, let's look at page 112. On page 112, strategies for comparing, it says look for the patterns in the fractions and decimals below. For example, 1 equals 2 over 2, which is equivalent to 4 over 4, which is equivalent to 8 over 8, which is equivalent to 1.000, which is equivalent to 1. Now, if you look at here, you have 7/8, 0.9, 0.875, all the way down to 0 over 2 is equivalent to 0 over 4, which is equivalent to 0 over 8, which is equivalent to 0.000. So on the right over here, and you don't have to copy this down, but let's just take a look at the general case. Case 1, same denominator or numerator of places. Fractions with greater numerator is greater. Ignore decimal point. Greater number is greater. So over here you have 3/5, 4/5. Now if you look, they're both 5, so the denominator is 5, so it's the numerator that determines which one is greater, and 4 is greater than 3. 0.75 greater than 0.5, the 7 is in the same place as the 5, so 0.7 is greater than 0.5. Case 2 says, same numerator or digits, fraction with lesser denominator is greater. If they have the same numerator, 6 and 8, but their denominator is greater, okay? So look at this, 6/9, 6/8. The 6 and the 6 are the same, but the 8 and the 9 are different, and 9 parts, 8 parts, well 6/8 is greater than 6/9. So the numerator that is smaller, and then they go on, let's look at fraction with lesser denominator is greater, which we just talked about. Decimal with leftmost non-zero digit is greater. So 0.3, 0.03, 0.3 is greater. Okay, because it says leftmost non-zero digit is greater. Okay, hopefully that makes sense. And let me get a different highlighter. Case 3, different denominators, find equivalent fraction with a common denominator to change a fraction to case 1. Okay, so 3/4 greater than 2/3. Again, here it's talking about finding an equivalent fraction, but look again, 3 times 3 is 9, 4 times 2 is 8, and 9 is greater than 8. Case 4, mixed numbers. Numbers with greater whole number is greater if the whole numbers are the same. Compare the fractions using cases 1 through 3. In this case, 5 is greater than 2, so 5 and 1/8 is greater than 2 and 9/10. Special cases for fractions. Case 5, denominators are factors of 10 or 100. Compare the decimals equivalents. 3/5, 4/10, and 3/5 are greater. Now, if you think about this, 5 times 4 is 20, 10 times 3 is 30. It says denominators are factors of 10 or 100. Compare to decimal equivalents. Okay? Case 6. One fraction is greater than 1/2. One fraction is less than 1/2. Fractions greater than 1/2 is greater, so that 5 out of 8, 4 out of 8 would be half. 3 out of 7, 3.5 out of 7 would be half, so 5/8 is greater than 3/7. And then it goes on to say use strategies to compare. 0.76, 0.67, the 7 and the 6, 7 is greater. 5/8, 5/6. Again, 5/8, you could look at the 8. Oh, look at the 8 and the 6. The 5s are the same. The 6 is smaller, but 5 parts out of 6 is greater than 5 parts out of 8. And in number 32, 0.09, 0.1, remember 0.1, closer to getting to a whole, is greater than 0.09. And then the last 4/9 is less than 3/5. 9 times 3 is 27, 5 times 4 is 20. This concludes our lesson for tonight. Your assignment for tomorrow will be 3.9 in class. Just take a look at it. Adding and subtracting, more of the same. Comparing, trying to use these strategies. And then the remembering side, more of the same as well. Nothing jumps out at me that would be too difficult. So make sure you finish 3.8, and we will work on 3.9 tomorrow.